Thanks everyone for joining. We are going to be talking about the necessity of the digital toolbox. This is primarily meant as a support tool for the people working in the field for our primary industry is the oil and gas industry, but it can be used in different industries as well. The focus is to explain what digital tools can do to help people in the field to execute their work. The agenda will be a quick introduction about Hint for the people that do not know us. We'll talk about some network challenges, some network advantages for moving into the digital space. Then we will dive into the digital toolbox, talk about some benefits, have a quick explanation about the tool that we have made with the called digital toolbox practically. Also talk a little bit about the mobile application, and then we will have some time for some questions. So the company that I work for is Hint. Hint has been in the business for the oil and gas industry for about 27 years, 27, 28 years. We have an office in the Netherlands, and we have an office in America. We do mainly software development nowadays, but we do have a history in the oil and gas industry. Our boss has been a former employee from Shell, for example, and we also have consultants that are from the industry as well. Next to working in the oil and gas industry, we also do app development for example, waste management. So we have been working on, for example, an app to have the Uber concept for trash in America. And we work on many different aspects of development for IT products as well. Me personally, I am the product owner, Wilfred Brink from Hint. I've been working with Hint for about 6 years. I started out as a commissioning engineer. I worked in many projects in the Middle East and in Americas, and through my experience that I have gathered working over there, and especially being recently graduated from an IT school, I noticed that there is a lot of processes that are still done either manually or through Excels or other inconvenient ways compared to what I was used to work with coming from a school where you are literally working with IT tools all the time. Through that experience, I talked with my boss and with my colleagues, and I was like, well, we really can help the people to make things easier and better and support them with digital tools to make the work more efficient and hopefully more fun to do. It's not meant to be a replacement because the work in the field, as I will explain later, is always still mandatory to be executed, because without sufficient quality of the resources in the fields, IT tools are fun, but they won't do anything. I will first talk about some architectural challenges, because this is what is holding our industry back the most. To be able to take full advantage of the new ways of working, as some people like to call it, is that you do need your information available on broader levels. If you only have your information available within your premise, then it becomes very difficult to do your investigation remotely, but also to have alerting or notifications on a distance as well. We've seen, especially with the COVID-19 swooping throughout the world, that it becomes very difficult that if you do need to be distant away from each other, or you can't be on the plant or anything like that, that getting the information or getting the notification of what is happening in the field is very difficult in some situations, especially if you have a brownfield, like an older plant. You do run into the problems that you are reliant on email and telephone communications, and that is way more insecure than having a system in place where you know that everything is managed and you know that you have appropriate authentication tools to make sure that your information stays as safe as it can be. Obviously, if you do expose information to the internet, you have the risk of being hacked, But if you need to expose it anyway because you cannot work at the site, you might as well make sure that you do it in the ways that the big organizations like Google, Facebook, etc. do it as well, because those are shown to be the most secure ways that we know till to date. So with that, you get into topic as doing asset management in a cloud environment, for example. A cloud environment is nothing more than a pool of computers or servers that host a plethora of applications. There are some advantages there immediately, that if one of the server goes down, another server can pick that task up, so everything keeps running. So that will give you more uptime on your IT infrastructure than just having servers on site. Next to that, with the big cloud service providers that are out there nowadays, uh, you can have more trust in the IT environment as well, because holding your own team on an on-site basis is way more difficult with having all the SMEs at hand and making sure that everything is being done efficiently than to do that for a company that has their main business around that use case. You would then have to think about how information can flow from your instruments or from your systems all the way up to systems like that. Obviously, you need to make sure that the flow of information is uninterrupted, because if you get gaps of that information, you need to make sure that that is minimized and also controlled, that if something goes down, that you have systems in place that give you information about that. So redundancy, virtual machines that can start up and shut down very quickly or be replaced, all these kinds of terms will have to be used to make sure that the uptime and the quality of the data being shared from the lowest level all the way up till data historians or even cloud environments is of sufficient quality to make sure that everything is being captured in a way that it's trustworthy enough to make decisions on later. You then also get in the space of the IT team. They might not be very happy with having to manage a link to the outside, because that's always scary. But links to the outside to a certain degree are needed. Nowadays, you do your banking through your mobile phone. You don't hold any cash money. All the things that give you power in your personal world is something that has been looked at in the oil and gas industry as still being very scary and dangerous, even though there are enough proven concepts out there that show that it's definitely doable, and if even managed by the leading companies, very efficient as well, and not even that costly. When you move from on-site to a more broader accessible environment, you also get the benefits of being able to have, for example, a central base of SMEs, inviting your suppliers to be able to have a look at situations that are happening, because when problems arise and they need fixing, your technicians or your engineers or whoever is going to troubleshoot the issue is going to share information anyway, because the problem needs to be solved some way. Um, so again, it's better to have that control yourself to make sure how information is being shared. It's easier to give someone access into a system and do that in a secure way than making pictures or sending documents or all these kind of different ways to get the information across to how you solve your problem. Next to that, I will talk a little bit more in detail about it later, but also mobiles, for example. Working with pen and paper in the field is especially difficult because like I'm an IT person. If someone has to go through my handwriting, I wish them very much good luck, because my writing isn't the best. And from experience, we all know that human error, especially from notes and keeping notes around and making sure they don't get lost, and going through all of that at the end of the working day again to fill it in into an IT system, is something that is just redundant, prone to error, and also very cumbersome as well to do. So it would be better for the technicians as well to be able to fill it in at the spot so they don't forget about it. It's more accurate and there's no time in between that as much as having to do that at the end of the day or forgetting about it altogether because they had to go somewhere, for example. Advantages with changing the infrastructure. Um, there are possibilities to set it up faster. Outsourcing or managing your IT in a more centralized space will reduce the cost for IT as well. Accessibility and security can be increased, but it does depend on how you set it up. Maintainability, it's more centralized, so you have less moving parts like standalone servers. You create the opportunity for 24/7 monitoring, even if you're not on premise as well. And those together can very much, those combined can very much help you to reduce the IT cost, but also the trust in the IT systems, because that can also be a issue for companies to have that trust in the systems and not to fall back in the old ways of just going out into the site and figuring it out on the spot rather than using the systems what they're for. I was talking earlier about that the work in the field will always be mandatory. That comes down to this picture. The information that is being gathered from what happens in the field is dependent on the quality of the measurement that happens in the field. The quality of the measurement is built up out of the triangle that you see on the left. So you have the quality of design, which is then implemented, where you have the quality of conformance, how well the design was followed, and that will result in a quality of performance. This circle can go round and round and can be improved upon until you reach the performance and quality of measurements that is desirable. And after that, you can move into quality of data and quality of management. If you do not have sufficient quality of measurements, you get the garbage in, garbage out principle that you will be looking at data or you will be making decisions on information that is just off the mark. So by default, also your decisions at the end will be off the mark, or well, unless you're very lucky. But in most cases, your decision making will then be off as well, and that will cost money and will have consequences. The normal work process for what we do in the field. If you go in the field as a person, you start at data acquisition, you go to the analyzer house or whatever it is that you are going to investigate. You are going to do data acquisition. So you are going to look at the situation and assess. For example, you will read the screen and see the information in that way. So what are the reading values? Is there anything that that comes to mind that you need to pay attention to immediately? But next to that, you also have secondary information like, is there excessive sound? Is it a messy situation? Is there smoke or any unusual extra information that doesn't come from the equipment itself? And this extra information is also very important, especially when you start working with IT systems, that it needs to be captured in a different way as well, because otherwise you are looking at an incomplete picture and you might miss what is actually happening in the field. After you have gathered all that information within your mind, you're going to process that, you're going to analyze it, and you are going to make a decision. Is this status normal or is it not? That decision making of is the health status normal or not can be very different between someone that is an SME about a specific topic or someone for who it is its first day. The person that sees it for the first time might think, oh, everything looks nice, everything looks normal, everything is within its limits. And an SME might be able to say, hey, I see that it's still data because it's not moving enough. I do need to do some further investigation. These are examples of where a digital toolbox can really come in handy, because the knowledge of the SME can be leveraged as tools towards someone that's, for example, new in the field. So these are examples where you do not want to replace the person in the field, but you want to help them with additional tools to make sure that when you are doing the maintenance or the visual inspections, that that person is properly equipped to make sure that there is even the small errors are being noticed. So if the health status is okay, you just move on, you go to the next piece of equipment. If the fault status is not okay, you are going to investigate what is the fault. You are going to make a prognosis and you're going to make a maintenance decision of how to fix it. Then you are going to execute the fix and you are going to confirm that everything is back to the state that it's supposed to be in. And then you can either do the condition monitoring one more time, so the data acquisition, processing, analysis, and health status to make sure that it's okay, or you can move along and check it, for example, the next day, especially if there's long cycle times or leading times to which you can check if the fix has helped. Um, Things like fault diagnosis, prognosis, and maintenance decisions can, for example, also be root cause analyses. So when you do figure out that there is a problem, root cause analyses can also help you to figure out what the fix is to make sure that you next time you go into the field, for example, if you need spare parts, that you have the appropriate tools to fix it, or that you already immediately know that you need a certain SME. So it very much shortens the downtime through like building knowledge to how to solve specific problems. Now diving a little bit deeper into the toolbox itself. Um, so what would you need for a toolbox to help the people in the field? Like if you have the physical toolbox, when you go into the field itself, you have your normal things like a hammer or a screwdriver, etc. So that's the tools that you need in the field to be able to execute your work. But when it comes to digital tools, you, for example, need to know the data from the field. So what I talked about with the initial picture, you need to know what your process values are. You need to know what the diagnostic information is. But you might also need to have, for example, HVAC sensors in the building to make sure that there's no smoke alarm, or pressure, temperature, or those kind of extra sensors in that building to make sure that the secondary information that I talked about is also available to the maintainer. Because the information that is available, for example, in a control system, is usually zoomed into primarily the process values. But a maintainer is reliant on more information to make an accurate fault prognosis to be able to see either if there is something wrong and if there is something wrong to come up with a potential fix or root cause of the problem. Next to that, you also want tools to help you find problems. So when you have that information, you can, for example, do things like trend analysis. So you need the history of the information and not just the information that is available at this moment. Things like statistical process control, control charting, historical charting, statistical analyses. All these tools can help you to identify, is there a small error or is there even a big error already? KPI tracking is another example where you can see that if, for example, the utilized rate is dropping below 90%, then you might want to change the maintenance protocol for that piece of equipment. Or if you already spend a lot of maintenance time on that piece of equipment, you might even want to consider replacing it altogether and finding another tool for the situation. That kind of information is difficult to come by when you are doing everything from the field alone. Then it all comes down to memory, Excel sheets, and sometimes even gut feeling. Gut feeling is something that is very difficult to program into a digital tool, and it can be very helpful. But if you combine accurate information with gut feeling, hopefully we can make that next step and bring the maintenance cost and downtime down even further. Next to that, you can do, next to that, a tool is, for example, tracking your maintenance. So if you have, for example, two GCs in a different environment, and the one GC is having nearly no downtime, and the other one is having a lot of problems and needs a lot of maintenance, you can do cross comparisons to try and figure out what the breaking change is between the two environments. that can also help you, for example, between different people that work on it. So if your SME has worked on something, has found out the fix to a certain situation, then the next time you might not need that SME to execute the job, but you can use someone that is less experienced. So he can be trained as well and gather more experience about that topic. And of course, as last part, you want reporting, because your manager wants to know what has happened, your team leader wants to know what is happening, and nobody really likes to get into the office at Monday or Sunday, whatever the starting day of your week is, and have to spend the first 2 or 3 hours going into some office tool and build a report every single time over and over again. That is something with modernized digital tools that is just either a press of the button or automatically where it just is there for you. You can double check it one more time and you send it to your manager, and you can go on adding value to your company instead of spending all that time on a report that, yeah, doesn't really help you do your work and is also usually not the most fun job to do either, especially when you look towards emission monitoring, for example, where they are very um, strict with the reporting as well. That can, in most part, be automated to make sure that you only have to check it. You can spend a minimum amount of time, and your information is going to be accurate because everyone is hopefully using the same toolbox. So through that, everyone is looking at the same information, and you do not have gaps or lost Excel sheets, or you won't be able to trace what has happened, for example, through someone changing something. Those are all things that come together in a digital toolbox. So for example, you would have audit trails to see who has made any changes as well. So if you do see, hey, I see something is different from the last time I've been working on this, then you could also investigate who has been changing things. And that is something that particularly in Excel is very difficult to do. So what are the benefits? Um, Benefits for a digital toolbox would be to supply field personnel with advanced digital tools. So for the investigation of problems and also the registration of how to fix problems, to and to get information over time is all the tools that people in the field really need. And that can go from just simple process values to blueprints of the entire drawings of what is the current state in the field. Everyone that has been in this business for a long time does probably know that the binders full of drawings of what the supposed current state in the field is, but after 10 years, a lot of those binders are out of date, and the situations have been altered already, and you come up with schematics that are 80% correct, and then you have to do further investigation to figure out what the actual status is. Those are problems that really shouldn't be happening anymore in this day and age with all the tools that are available out there and all the, the benefits that you can have from the tools that can be created to prevent those problems. Um, Next to that, you have boomer knowledge retention. Um, a big portion of the SMEs in our industry are people that have passed their 50s. But that knowledge needs to be transferred somehow. And yeah, I don't think most of them are teachers. And I don't think they want to all stand in classrooms teaching younger people like myself, for example, to transfer all that information. So providing that information to tools and being able to configure root cause analyses, for example, back into a system will make sure that that information is to a certain degree stored and handed on to the next generation of people that are going to maintain the industry as we know it today. Um, with that, you can create a backlog of the root causes. So you can also immediately, by the time you're troubleshooting a problem, go through the most common scenarios where you can go off the checklist, like Are these phenomenon happening? No, 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 no. Okay, then you can strike out a couple of root causes, and you can minimize the plethora of information that you have to look at. And through that, you can then also make the troubleshooting process more efficient as well. Of course, the increased availability and accessibility. So not being restricted to going into a control building or being restricted to going into an analyzer building to get your information, but instead of that, potentially even being able to do that from your home, or being able to do that at least from the office network within the company, so that when you get into the office in the morning, you get your cup of coffee, you can turn on your laptop or your PC, and you can just immediately, while talking to your colleagues of how your evening was the last day, investigate and see, hey, what is happening in the field? Is there something that immediately requires my attention? Or can I just have a conversation for 30 minutes or go into that meeting that has been scheduled already? And after that, it can also help you with prioritizing what problem to go through first. If you first have to go into the field to figure out what is happening in the field, then the prioritization of what needs to be done that day can be very difficult sometimes, because your calendar is fully booked with meetings, or you already have your PPM task pending and you know that you have a lot to do today. That might mean that the actual most highest priority task is being delayed because you simply don't know it exists. So through the availability and accessibility, you can always make sure that you are on top of your priorities and you are chasing the problem that needs fixing first. With all the information that is available, of course, we are striving to move from problem solving towards problem prevention. If you find the small errors and you are capable of anticipating on the small errors, uh, a lot of the problems can be prevented, and that's really what we are trying to get to. The time of firefighting and just chasing all the failures in the fields is something that we really want to move away from, and that is actually in a large case, or a large portion of the cases, possible as well. Um, Obviously, we want to be in the smooth running of the plant. We want to minimize the downtime. We want to keep the operations running, and we also want to have operations having trust in the equipment that we provide to them and the readings that they are dependent upon. Another example of today's technology that is very normal in our everyday life, but not so normal yet in our professional life in the oil and gas industry, the use of the mobile phone. If you now see the next generation, or maybe your children, how much they are capable of doing with their mobile phones nowadays, it's sometimes amazing. But for a lot of people in our industry, it's still something that they barely really use within their professional life. Of course, you do your messaging and that kind of stuff, but you might not be able to, for example, write down what maintenance activity you've done, or be able to get your KPIs of the instrument that you're standing in front of. This is all, these are all tools that, are already possible, definitely, and should also be possible in the field. Of course, you do have to keep in mind things like explosion proof and work out ways how to do that safely. But that is something that is more of a architectural challenge than a IT problem per se, of being able to supply that as a tool. So the tools are there. We just need to be having that conversation and having that discussion of how to be able to make that available to help the technicians and engineers to do their work more efficiently, and to make it easier to execute for them as well. With that also, if you do have a leadership function, for example, you would be able to connect the important notifications or the big alarms as push notifications to your phone as well, to make sure that if something happens in the field, you are immediately aware of that happening, or you could automate reporting or emailing reporting and that kind of stuff, and be able to receive that through your phone as well, to be able to uh, react to important actions that happen within the field. So, as a closing statement to digital tools, um, we obviously want to be running in smooth operations. We want to be the sun with the sunglasses. Uh, Unfortunately, we all know that isn't how plants run. Small errors will appear, and we want to capture those small errors. We want to make sure that we want to try as hard as possible to be at the small errors, prevent the problems from that moment onwards. After that, you do hopefully be and get the information from the tools that there is a change in performance. By that time, you know for sure, hey, I need to react on this. I need to start prioritizing this piece of equipment, because if the performance starts to change, it's not long before you get towards impending failure or altogether failure. Even if that is out of your hands, you are still capable of anticipating by making sure that you have either the spare parts already in place to fix it, an SME is already looped in, or you are already talking to your supplier. So through the digital toolbox, this entire picture is something that you are going to be better on top of, and you are going to be more efficient with. Um, Show you a little example. Our tool is called AML Information Management, and it is our digital toolbox. I will zoom in on a couple particular topics of that to give you a bit of an insight of how what it looks like in our system. So on this screen, you see the overview. It is our demo environment. So you see, for example, on the left, you have Hint Corporate Office. And then you have Hint Houston, Hint Manama, Hint Wapenveld. So that are like 3 locations. And then on the picture that you see, you can immediately see the current state of the underlying areas and everything that lies underneath there. So, for example, you have a blue square and 2 green squares. The green squares will tell you that there is nothing underneath those areas that have a state worse than utilized. So everything within those areas is basically fine. On the one that is blue, the worst state is non-routine maintenance. So there has been some problem, but they are maintaining it and they are fixing it. And there is also an alarm indicator. So through this, if you do this from the top level, you can immediately see for your entire plant if there is a fault alarm or a fault state or some alarms. You can see if there's maintenance being done, and you can immediately see if the entire area is being utilized without any problems. You can then click on these areas, and then it zooms into one level lower, and you can keep doing that until you find the area or the instrument that you're interested in. Through that way, you can do visual inspections to a certain degree within a couple of minutes, instead of having to go through the entire plant. If you only have 20 analyzers, you can make the case, yeah, I can still do it through visual inspection fairly quickly. But if you run a plant with 1400 analyzers, doing a visual inspection is just something that is fairly difficult to execute. Next to that, you also have the performance indicators. This is the same information of the current state, but then in time. Also, another thing that is fairly difficult to do from the plant itself, because then it comes up to you either having written down when you had your downtimes in an Excel sheet, and calculating how much of that time is being downtime and how much time is fault state and how much time has been up state or available. But here you can see that immediately. And this also works in the same principle where you can choose whatever you want to look at. So if I would, for example, click here on availability rate, then it will show you below from the areas that are being displayed, how much of that is being divided through those areas. So how much of those areas are having the availability rate or fault rate, etc. And then you can again click on those areas or there's an instrument to keep on zooming in until you find the area or the instrument that you're interested in. So if you would do that, for example, with fault rate, you can immediately see where most of that fault rate is situated. So you can zoom in to investigate where you might need to do some more maintenance. If you then get to the instrument itself by drilling all the way down, you again get that same information available here as well. So you can see in the top right, you have your performance indicators again, but now filtered all the way to this instrument. And on the bottom, you can also see what the operational state of this instrument is. So through this, one functionality, you can do a lot of your investigation of bad actors, for example. You can see where most of your maintenance time is being spent. You can see which of your instruments are having a lot of issues, but you can also see the instruments that are working absolutely fine and that you might want to reduce the amount of maintenance for because of the very good uptime that they have. So with this live information that you get from the field, what the status is of your instrument, you can already gather very valuable information of how your plant is running. And this is crucial for technicians and engineers, and especially for the people that set up the maintenance schedules to make sure that your maintenance plans are according to the needs of the equipment. Because planned preventive maintenance is obviously something that is very valuable and needed, but it is something that is always a little bit too early or a little bit too late, because getting that absolutely perfect is almost impossible. But through having the live information from the field, it can give you indications of being able to tweak it slightly broader or stricter for the piece of equipment that you're looking at. So it can give you that last bit of valuable information to do either cost cutting or incentivizing to be able to prevent the problems that are happening. What is fuel for most of the KPIs obviously is operational state history. So this is something that you could do manually in case your systems aren't smart and aren't capable of communicating that through automated means. But if you do connect to GCs or if you get that information through a control system, for example, you can completely automate that process as well. Next to operational states, there are also KPIs possible about the amount of maintenance that's being executed. You can get KPIs about, for example, how well validations have been executed, all these kinds of extra KPIs to give you an insight of how well that piece of equipment is performing, but also how much time has been needed or by the technicians or the engineers as well. Again, from our perspective, this tool is not to scrutinize the technician. It is feedback that we have had before, like, yeah, my manager is just bashing me because I can't get the availability rate to the level that it needs to be. But it can also be a tool for the technician to go up to management and say, hey, I've done all the maintenance that has been required by you. I've done all the work that you asked me for, but I can show you with this trend or with this information that this asset is just not right for the job, or that it needs replacement, that I need budget for it to replace it, for example. So this is just to create transparency between management and the people that execute the job. Give the information to be able to have that discussion to make the whole better. That's the goal of this, not to have managers being able to scrutinize the people in the field and to say, hey, the uptime is not good enough, make it better. Maintenance planning and scheduling. There are the big systems like Maximo, like an SAP, etc., that have the maintenance packages. The big downside of their maintenance packages is that they do not have live information from the field. So you cannot anticipate on what happens in the field. So you get down to just plan preventive maintenance and break fix maintenance. With the information live from the field, you are also capable of creating triggers. So if you, for example, see that the flow is starting to go down, you might have a plugging issue. You can build a trigger based on that that immediately generates a maintenance task and assigns it to me, for example. And then I can go into the field and check if there is a plugging issue or if there is any audio issue, but at least I'm going to investigate why the flow is going down. These are for examples that, yeah, where a Maximo or an SAP or any offline uh, maintenance tool is just missing the mark, in my opinion. You need that live information from the field to do active or accurate maintenance and to make sure that you are on top of what is happening in the field. Next to that, you also have the tools to investigate problems. So here is an example of a control chart. In the bottom are a list of statistical rules that are being applied to this control chart. So based on the validations that you have done over time, you can have a more broad picture of what is happening to that instrument. Your instrument might be having validations that are perfectly within its limits, but it might be trending. That is something that you can see through control charts, for example, or that is slightly off center mark. So it might be all just above the center mark. Then you want to do a calibration to bring it back to the center mark. These are, again, tools and uh, tools that are very difficult to do manually from the field. You can do them through Excel, it's definitely possible, but it takes a lot of work. And here you just enter your validation results, you do that diligently, or even if they're smart instruments, the validation results can be gathered automatically, so you don't even have to do any administrative work. You just do your work in the field, and then at the end of the day, you spend 30 minutes, 1 hour. You go into the system, you check all the instruments that you have been validating for that day, and you go through the control charts and check, hey, is my instrument still running correctly? I did see when I was at the instrument that my validation was correctly, it was within its limits, but is it trending, or is it, do I have an offset problem, for example? It can just help you to make your work so much more efficient within and from better quality as well. Same goes for this chart. This is the historical chart. It has some different calculations, but again, it's tools to help you find any of the problems when it comes to validation results. And next to that, obviously the reporting. So what we find very important in our company is that our best people have the same capabilities as our newest people. So I'm a product owner, but if someone from my development team uses the application, I want them to be able to do exactly the same as I am capable of doing. So we have built everything that I can do back into the system in a way that it's available to the users as well. So there is no coding needed, for example, to build a report. We've built a whole interface where users themselves can create reports themselves. So we have whole packages of information, and you can use those packages to build up a report by a drag and drop system, for example. But it goes further than just the reporting. We've also done that within the application itself for example, I/O configuration. If you want to configure some new Modbus or OPC addresses and get extra information into the system, then it's just a matter of putting the information in a free. It's like you give it a name, you fill in the tag, for example, an OPC tag, and you determine what the data type is. Those are all ways where we want the user to be able to maintain the product, because especially with maintenance tools, it will change every time that you're using it. It will change based on your experience. So the tool needs to be able to change with that situation. So you need to have the freedom to adjust practically everything. Because if that's not the case, you will come up with questions and you won't be able to do it. And then the system becomes more of a burden than something that supports you in your everyday job. So that's something that we find very important, that you are capable of managing your own toolbox, essentially. That's what it comes down to.